So here we have our 4-channel ML4035 TDR. And we're going to utilize this equipment today to validate the impedance mismatch on this PCB board that we've recently received from a fabrication house. We have 2 channels that have an impedance mismatch of 20 ohm that is causing a signal integrity issue with regards to our application. And using the 32 gigahertz bandwidth of our TDR, we will utilize this tool with our software to check this mismatch. So first, we connect to our equipment via fast Ethernet. We select the channel that is connected, which is in our case channel 3. And we start the calibration procedure, which is a simple 3-step calibration that will be automatically guiding us through this setup. We click on calibration run, and then we just remove the DOT, which is already removed, and we click next. Once connected on the first step, we move to the next step. We basically have the system open because we're considering that these cables are not part of our system setup. Anything connected from these cables onwards will be considered our point of start, which is our DOT. So basically we just click next step as well. And third, we need to attach 50 ohm termination on each of the differential channels. So you will have a reading of about 100 ohm. And we click on confirm. And as you can see, calibration is completed. We just click on apply gating, and then we close this GUI, and we click on confirm. Once we click on confirm, we open the TDR GUI, and here we have an impedance profile of about 100 ohm. And once we click on play, we see that it's a continuous pulse and it's always constant. Moving on to our physical setup, we have 250 ohm terminations. Removing them will open the circuit. So you go to the GUI, you will notice that we have a gated value, and now it's time to connect our equipment, which is our device under test, on the edges of these cables to see and highlight the impedance mismatch. So now that our 50 ohm terminations are removed, we move on to connect our DOT, which is basically going to be the 2 channels that have an impedance mismatch on the PCB. Now we move on to the hardware itself. We take on the DOT and we connect to the first channel. So now that we're connected, we move on to the graphical interface and click on play. You will be able to see that by zooming in, that there is an impedance mismatch on this channel itself. And this is going to be shown as we replace channel 1 with channel 2, which will supposedly have an impedance profile of close to 100 ohm. So what we can do is place a marker on this channel here, and we will see that it's about 117 ohm for this particular input. So here comes the utility of our ML4035 TDR. The flat signal should have been 100 ohm and the connection with a 5% error margin. But here we are reading 117, 118 ohm, indicating an 18 ohm mismatch from the original design that was sent to the fab house with an initial value of 100 ohm. So the use case here of our TDR was to highlight that the unit was poorly fabricated in the production house, and here what we're going to do is switch to the second channel that has an expected impedance profile to highlight it as a secondary signal on the display, so you will be able to compare between both signals. So here we intend to switch to the second channel. Switching to the channel that has the expected signal integrity, we should move on to the GUI and see a value close to 100 ohm for this particular impedance profile, which is the case here, as the value of 101.79 ohm is different than the value of 118 ohm that we previously got on the previous channel. As you can see, we have the channel that we are currently measuring has an impedance profile of close to 100 ohm. And moving on to the channel that was previously loaded, we look that there's up to 20 to 18 ohm impedance mismatch between the traces. And this will wreak havoc on measurements, especially at high throughputs. So, in conclusion, we can say that our ML4035 solution is an affordable yet accurate tool for measuring impedance mismatch between test traces for all or most PCB manufacturing houses, as is the case with our experiment here in front of you in this video. And the good thing about this is that we also are coming up with a portable version of this ML4035 that will be able to do quick probing of channels in any lab environment.